All right, real quickly, I want to run through how to change repeating decimals into fractions. Basically, there's three different cases that we have to deal with. The first case is when we only have repeating digits. So what I mean by that is, let's take one that we know, say we have 0.3 repeating. Of course, that's 0.333 forever and ever and ever. Now, the trick for turning a repeating decimal into a fraction is to take the repeating part and put it in the numerator. In the denominator, we're only going to have nines. Since there is one digit that's repeating, I'm going to have 1 9 in the denominator. Of course, simplify the fraction, divide numerator and denominator by 3, we're down to 1/3. If there are more digits that are repeating, for instance, if we have 0.45 repeating, I'm going to take the repeating part and put it in the numerator. In the denominator, since there are two digits that are repeating, I'm going to use 2 9s. So 45 over 99. Then simplify our fraction. Both the numerator and the denominator are divisible by 9, so that would give me 5 over 11. The second case is when we have extra zeros in the beginning before we get to the repeating part. So if we have 0.07 and the 7 is the only part that's repeating, then we can treat that as 0.7 repeating times 0.1. So because we scooted the decimal over one place to get to that 0.7, that meant we divided by 10 or multiplied by 1/10. So thinking about that, we do know how to write 0.7 repeating as a fraction. That'd be 7 over 9. And 0.1 as a fraction is 1/10, which will give us 7 over 90. Now, an even quicker way to go about this is, we can just jump straight to it. Say we got 0.0045, and we get to the 45, that's the repeating part. I'm going to take the repeating part, put it in the numerator. There are two digits that are repeating, so I'm going to use 2 9s. But then, to handle these 2 zeros that are out in front, I'm going to put 2 zeros in the denominator. So we'll have 45 over 9,900. Then, of course, simplify. Again, 9 is a common factor. So it would be 5 over 1,100. Maybe we try another one. Say we got 0.0265. And the 265 is repeating. So take the repeating part, put that in the numerator. There are 3 digits that are repeating, so I'm going to need 3 9s. Then I also have 1 extra 0 in the beginning, so I'm going to put 1 extra 0 in my denominator. Obviously, numerator and denominator are divisible by 5. When we do that, we'll get 53 over 1,998. The last case is when we have those extra digits in the beginning, but they're not zeros. So for instance, if we have 0.75 and it's only the 5 that's repeating, break it up into 2 pieces. Look at it as the non-repeating part, the 0.7, plus that decimal that is repeating, so 0.05 repeating. Then add the 2 fractions together. 0.7 is 7/10. 0.5 repeating puts 5 in the numerator. There's only one digit that's repeating, so it gets 1 9, but there's 1 extra 0, so we put an extra 0 in the denominator. Now we're adding 2 fractions together, so we need a common denominator, which means my first fraction has to be multiplied by 9 over 9. Then that will give me 63 plus 5, and my common denominator is 90. So 68 over 90, which simplifies to 34 over 45. So a nice little trick for simplifying repeating decimals in the 3 different cases.